Okay, so this screencast is going to address three different types of energy sources used in the United States: nuclear energy, geothermal, and fracking. Hopefully, the information that I obtained from this will help me choose a more direct content path for my research paper to be on. The first energy source that we're going to take a look at is nuclear energy, and this video is going to help explain a little bit about what that is exactly.
What is nuclear energy and how does it work? Since the beginning of the Industrial Revolution, the demand for energy has increased dramatically year after year. Today, the majority of this demand is met with the combustion of fossil fuels. With the recent disaster at Fukushima, as well as the ever-present effects of the events at Chernobyl and 3 Mile Island, nuclear...
Alright, so like this video says, energy sources have always been a big issue. Looking for the next best thing when it comes to energy. And also, like it said, we're heavily relying on fossil fuels in the United States, which is obviously not a renewable resource. So one of the good things about nuclear energy is it provides a lot of energy for the United States. But one of the cons about nuclear energy is whenever you're dealing with a nuclear reaction, things can go wrong, like at these three locations. Most notably, since I'm dealing with energy sources in the United States, 3 Mile Island, which was a nuclear reaction failure or nuclear reactor failure, which emitted a lot of radiation in the United States, which obviously we want to avoid when dealing with nuclear energy. And to get into exactly what nuclear energy is, I'm going to skip ahead in the video.
...are placed in rods within the reactor. The atoms of uranium undergo a controlled chain reaction which emits heat. Pressurized water around the reactor vessel is heated and circulated through pipes in a steam generator, which produces water vapor that spins a turbine attached to a generator.
Alright, so basically the nuclear reaction is going to take place in the reactor, and that's going to be either fission or fusion. And that just is going to basically make these mini explosions, which will turn the generator and produce electricity that we can use. So that's the benefits of nuclear energy, is that we can relatively harness this pretty well and pretty efficiently. The downside is, once again, whenever you're dealing with nuclear reaction, accidents will occur, like 3 Mile Island in 1979. Basically, there was a cooling malfunction where this communication between the cooling tower and the reactor stopped working somewhere along the lines, and this thing overheated, emitting a lot of radiation, which is obviously the main downside to using nuclear energy. The next source we're going to talk about is geothermal. And basically, geothermal energy is harnessing the heat of the earth. Once you get towards the center of the earth, once you get further and further down, the earth is obviously going to be hotter once you get towards that magma underneath this hot rock. So what geothermal does is it's going to harness this the heat coming off of this water and off this hot rock. And one of the biggest advantages of geothermal is that it's constantly available. That heat inside the earth isn't going away anytime soon, so it's pretty renewable. Like I said, one of the biggest pros on geothermal energy is that it is renewable, it's green, there's no products of combustion, and it's basically a long-term solution. The cons of it are it can't be transported like, say, nuclear energy or fossil fuels like oil and coal. But the main thing I want to focus on is fracking. And what is fracking exactly? Well, hopefully this video gives us a better look into fracking. And this is the most
The
controversial.
first part of the operation involves drilling straight down and then turning the drill horizontally to run for miles underground. The ability to do this is improving all the time. The aim is to reach the tiny fissures in the shale rock down there. These are minute, some are less than a millimeter across. That's where molecules of gas are locked away, trapped inside. Now, what's called slick water is then pumped in at high pressure. This forces the cracks in the rock to widen. Tiny grains, known as proppants, a bit like sand, are carried in by the water. They hold the fissures open. The technology of this keeps advancing. And the result? Well, with the rock broken up, the gas is released and flushed all the way back up here to the surface.
Okay, so what's basically going on with fracking is there's this natural gas trapped down into the crust of the earth, and in order to release that gas, we're pumping down water and filler with that water to expand these fissures and cracks in the crust and to allow that gas to escape where we can harness it and use it as energy. Now, the bad part about this is, well, in order to get that gas that we want out for energy, we have to pump down all this water and this filler, which isn't good for the environment, to pump all those chemicals into the earth. Um, so this, I think, is what's going to be my main focus in my research paper, and I'm gonna have to research this more and find out which side I'm on when it comes to fracking, because it is producing a lot of energy. However, it is detrimental to the environment, and we're contaminating a bunch of groundwater, which is becoming more and more scarce in the United States. And basically, we just don't know yet if the pros outweigh the cons when it comes to fracking. So that's what my main content path is going to be focused on, and that's where I'm going to spend the majority of my energy when it comes to writing this research paper.